let's move on to public business. So I'm going to start with an announcement. I sent a message out last night. It was somewhat belated. I apologize for that. But I hope most of you received it. It was sent broadly to our project list and our LSST science list. And it was about Mario Urich, our dear colleague. The message indicated that Mario has asked to step down from the position of subsistence scientist. Mario is one of the real heroes on LSST. He's been with us formally since 2012, most of that time as subsistence scientist. There was a period in the interim where we made him the lead of the data management system. He's had an incredible effect on the project, scientifically, technically, and just basically as a wise person with very good judgment about almost any issue that's come up. Fortunately for us, Mario's not leaving. He will remain involved with LSST at the University of Washington, both in a scientific sense and supporting the DM team at UW, specifically in the moving object pipeline area. But anyway, it's been a tremendous pleasure to have Mario involved with this project. And so, Mario, if you could stand, and maybe we could have a round of applause too. Now, when a vacancy is opened, we don't just sit there on our hands. So we're in the process of moving forward to the replacement, and there's a search that's being begun now. And Will, could you come up and just say a few words about that?
Yeah. So Mario's leaving, and that means there is some very big shoes that have to be filled on DM. So I'm looking for a DM subsystem scientist, and I think the concentration or a little bit the focus might be on validation of DM going into commissioning, as well as leading the science team and other things. So I'm here all week. If you have ideas, people you think would be interested, if you're interested, if you know collaborators who are interested, please send them my way. We are actively looking. I'm hoping that the job advert actually comes out on the Aura pages in the next couple of days. The text is all prepared, everything's ready to go. And I think that's all I want to say about it. And thanks, Mario.
So we have a bunch of interesting talks planned for this session. Beth, are you going to MC it? So let me call you up too.
Slides to go. Okay, great. So before we kick off this plenary, we've got a few announcements, changes to the agenda this morning. There's a couple of sessions that have been canceled, and during the unconference, there's also a special session that Victor is going to be hosting about working in Chile and moving to Chile, and that will be held here. Anyone is invited to attend. This evening, there's going to be a project-only team meeting tonight at 5:30 p.m. We hope that everyone will attend. It was great fun last year. And then, Chris, I'll invite you to step up to say a couple words about this evening's event, trivia, that everyone in the project and community is welcome to join into. And I'll give you this rock and roll mic. Yeah, there you go. Thank you.
Yeah, please join us, everybody, at 7:30 tonight here in the Grand Ballroom. We're going to have a trivia game. It's going to be put on by Geeks Who Drink. It's not a drinking game, but it is a pub-style trivia game kind of fashioned after those that are in the UK. And it should be a lot of fun, and I hope to see you guys there.
Great. It's a team game, right?
Yeah.
You form
yes,
teams.
It's a team game, so you don't need to know everything about everything, right? Because it's a team game, so the pressure's off a little bit.
Yeah.
Quickly, to avoid confusion, the text says 7, but you said 7:30. Which one is it?
That's the trivia question. Where's my team?
I think it's 7:30, but will the no host bar be set up at 7 for early socializing? Question mark.
That sounds
Great, so how about during the session, we'll get confirmation about exactly when all those logistics will begin. Thank you. Thank you for that first trivia question. And do we have any more announcements? I think those are the only announcements, so. Oh, there was a t-shirt? Oh, yeah, we got the clicker stop. Oh, thank you. I was hitting the wrong button. And t-shirts, there's more t-shirts arriving tomorrow, so if the table was out of your size, please go ahead by the table tomorrow. And there's going to be another photo at 5:15 today for those that missed it yesterday. And are they going to be photoshopped into the main photo? Is this a real announcement? So Suzanne confirms, yes, it is for those who missed the photo, and there may be some photoshopping opportunities to make us have a collective photo. And I do know that there were people photoshopped into last year's, and I bet none of you would have ever guessed that. So great, thank you. Unconference, here we go. Sorry, there's lots of awesome announcements. Unconference suggestions, yes. The unconference is this afternoon. There's some excellent proposed sessions that have been put up on these large sticky notes. Noon today is the deadline for proposing sessions. So please, at the coffee break, go ahead, put your ideas up on the board, and then a set of folks will take a look and assign the sessions to rooms based on the number of votes. Ones with more votes will get put into larger rooms. I hope that everyone has been identifying session scribes who will report back on Friday, just a minute or two, on the outcomes of each breakout. If only everyone was so lucky. I had Phil Marshall volunteer in my breakout yesterday before I even finished my sentence. Tomorrow, there's going to be a public talk that's led by Victor and Chuck Clavers. I think it's going to be pretty awesome. I hope we get a turnout like last year. This room was absolutely packed for Lucienne's talk last year. And there'll be a lot of members of the public who are interested to interact with folks in the LSST Project and science community. So please, if you're interested to interact with members of the public, come. Oh, where's my badge? Wear your badge and enjoy the evening presentation tomorrow. So let's switch this up. So the clicker's not working?
I'm trying to figure that out right now.
Super.
I'm going to try one last thing.
Okay, great. So as we make the transition here, the topic of this morning's plenary, as I briefly introduced on Monday, is the hidden heroes of LSST. And on the title slide, it says that everyone is the name of the presenter. It's really a cross-section section intending to represent all the effort that's being put in across the project to build LSST. Oh, good. And while I'm giving a little opening spiel, I'll draw your attention to item number 1 here. Midway through this plenary, we're going to take a little break and try an experiment where everyone's going to have the chance to contribute your thoughts. And so if you can do it on your computer or do it on your phone, and that way you can download the app and use just the phone network instead of the networking to be able to participate in this in the mid of the session. So there's a few different inspirations for this session. Oh, awesome. Thanks, Ian. And I'll just highlight one of them before being quiet and stepping aside to make room for all of our contributors. So recently, LSST participated in Asteroid Day, and one of the contributions for Asteroid Day was this wonderful video that was made at the University of Washington, and also with support from the local project office team, in particular Emily Acosta, Suzanne Jacoby, Amanda Bauer, and others. And here, LSST has a YouTube channel, and for the love of God, everybody do not go to YouTube right now and start trying to look at LSST videos, because I really want the networking to work in 40 minutes when we do this experiment. But later, you can go and you can find these Asteroid Day and other LSST videos on there. And when I watched the University of Washington video, there were students, postdocs, scientists, faculty, who all were saying words about what the UW team was doing. And I appreciated all the supporting work behind the scenes that went into it, and I found it to be incredibly inspiring and exciting about LSST. And I thought that in my head, in the next project meeting that I went to, Chuck Gessner just looked and he said, wow, that made me really, like seeing these videos made me so excited about LSST. And I thought, well, what a treat if we could just hear from a broad cross-section of the project. So the way that this is going to go is we've got these 12 folks lined up in this order, and we're going to take a little bit of a break in the middle. And for people that aren't familiar with the concept of a lightning talk, it's going to be a very strictly run 4 to 5 slides per person, 5 minutes only. I will stand up when it's 5 minutes. The speakers know I will physically approach them shortly thereafter so that we can keep things moving briskly. I think it's going to be a lot of fun, and the most important thing to me is that everybody who's watching and enjoying these presentations gives a huge amount of support and enthusiasm for everybody getting up to say a few words about who they are and what their work is. Especially because, you know, not everyone is as used to getting up and talking about LSST as I am and some of the other people who are always up here. We're not going to take any talks between the presentations in the interest of fluidity, but I would, did I say talks? Sometimes any questions between the talks, thank you, John. But what I would do is encourage everybody who thinks of questions as you're listening to these folks speak to bring those to the project team event, to bring those to trivia and to the social times, to, you know, maybe look at some of the folks who are up on the stage and think, oh, I don't know who they are. Maybe I want to invite them to be with me on my trivia team, okay? So we're going to go ahead and kick this off with Brian from Slack. Maybe like clap for everybody collectively. Do you want to use the remote control?
Yeah.
Do you want to use the hand mic or the?
I'll just use this mic.
Okay, great. And I'm going to turn my computer around and you'll see a timer too.
The clicker works. Use the left side. Oh, I'm sorry, the right side.
Hi, everybody. I'm Brian Van Cleveren. And if you didn't know my name, well, I didn't either until I turned 5. So I actually found out on a birthday cake. I'm a software developer at Slack. I've been there since 2010. I work on the Fermi Gamma Ray Space Telescope as well as LSST. I work in the data handling group for that at Slack. And I've also worked for the desk and some other projects at Slack. Before all that, I worked at the University of Utah in the on the high-res and telescope array cosmic ray detectors, and somewhat famous for discovering the oh my god particle. And so mostly that just meant we walked around a lot in the middle of the desert and fixed GPS antennas on surface detectors. In my free time, I like to cook a lot. I love Jacques Pepin. I like playing music and hiking around the Point Reyes seashore in Northern California. In one sentence, what I do for the project is I work on the DAX team, building HTTP data interfaces, so just web interfaces, and databases, and helping out with Slack, and attempting to know a lot about the IVOA. And we'll talk about that just a little bit more. I actually got started on the project Nebulous 3 years ago, working on image and metadata management, and that sort of parlayed into working on the web interfaces as part of the DAX team. And as part of that, I've also been active in the IVOA community, and it's great because I get to go to places like Shanghai and South Africa, but not so great because you have to do a lot of stuff with XML. Before that, I was sort of helping out sort of tangentially with the LSST project in the camera, mostly the data handling and some applications along that. A lot of the tools are actually derived from the Fermi Gamma Ray Space Telescope. As part of DESK, I also help out a lot with the computing infrastructure and the data challenges in Twinkle's project. And I'm also a convenient desk DM intermediary, partially because I'm on both. And part of the reason, because I'm on both, I kind of got put in this position where I was implementing Slack for the project and the community. I was sort of just a good person, also with the web interface background, so got sort of happily stuck in this position. A year ago at this meeting, we had worked on trying to figure out how to extend Slack, which we were on HipChat for the project, and bring the community and everybody inside all in one sort of team. And so here's a little plot of the Slack history, and you can sort of see the beginning right after the meeting a year ago where we were starting to test things out, and then the initial bump when we started bringing project DM people in, and then there's a few more bumps where we brought camera people in. And the big bump early on was just bringing in desk people, and then the holidays. And you sort of see that it's been steadily increasing over the last year, up until a sort of peak about a month ago. And this was the desk collaboration meeting. So we have about 382 active people that week that were checking the application, and 283 people participating by sending messages. It's probably going to be similarly busy, barring internet issues this week. Just a little information on getting onto Slack. The only real requirement for really to get on the Slack is you should have data rights, but it also helps if you're in the contacts database for the project. And if you don't know what that is, you can also email me. And it's also good if you're in a science collaboration, because then you have people to talk to who have some sort of shared goal in mind. How to get on Slack if you're not on it, which you should be. If you're in a science collaboration, try talking to your chair. Otherwise, you can email me directly, but there's only one me, so we're trying to figure out how to make a more sustainable way of getting people on. So that's all I have.
Okay, so you can.
Okay. Good morning, everyone. So first of all, before even presenting myself, I want to point out my personal fun fact, which is that this is my first presentation in front of a crowd. And one of my biggest fears is, thank you, my biggest fears is public speaking. So I've always been more of a behind the scenes type of person, so please bear with me on this. For those of you that don't know me, my name is Carol Chirino. I'm the Senior Site Administrator in La Serena. And just to give you a little background about myself, I was born and raised in Edmonton, Alberta, where I studied administration at the Northern Alberta Institute of Technology. From there, I started to work directly at the University of Alberta Hospital. And after a few years there, I moved to Chile, where I joined the Administration and Facilities Group at Gemini. And after 8 years there, it brought me to my current position at LSST. So my contributions to this diverse organization is mostly in the administrative area. Since I was the first admin to start in La Serena, I've had the opportunity to be involved in various areas of the project. From the first dome celebration to preparations of construction, the arrival of employees and contractors, documentation of procedures and policies, and safety issues. And pretty much anything and everything that's brought to my attention. As most of you know, we're a small group in the South, so we're a very close-knit team there. When we have visitors and colleagues, we like to make them feel at home. And we've had some of you visit us already down there, and I really hope that your experience was a good one. I mention this because for me it's important to, as part of my job, to make our visitors and colleagues feel welcomed and maybe feel part of the team when they're at the site. So there is never a dull day working at LSST in La Serena. There's always something new, either on the summit or in the base facility construction. This has given me a lot of experience in different areas where I wasn't involved before, mostly in the technical aspects of the construction, also of the building. So I'm also involved in that as well as coordinating logistics for the summit team and for the contractors, maintenance of the LSST vehicles, and so on and so on. But I also get to go to the summit, and this is one of my favorite parts of my job, because when I first started to work, and I go to the summit, there was nothing, just pretty much rock. And then I got to see how it progressed, and just to see how the building is right now makes me really proud to be part of this project and part of history. So this is just a general overview of what I do. So I do encourage you to please stop me in the halls. I'll be at the registration table. If you have any questions regarding visiting Chile, I can help you with anything. So thank you.
Hello, LSST. For those of you that don't know me, my name is John Andrew. I work for the Telescope and Site Group as an engineering associate. I started working on the project in November of 2005, so I've been with the project for quite a while. Prior to LSST, I worked on the Gemini Near-Infrared Spectrogram and the NOIRLabAstro Extremely Wide Field Infrared Imager projects. So I'm familiar with telescopes and astronomy. I have over 30 years of experience using many different CAD systems for engineering. I also have a chance to teach some night classes at the local community college here in AutoCAD at geometric dimensioning and tolerancing. And this has given me a great respect for those who teach. What I do for LSST is I design some of the mechanical equipment and processes for the Telescope and Site Group. I also manage the baseline design and the as-designed CAD models and drawings using PDM software. And on this slide, you can see some of the drawings that we use for the ICD to try to communicate this mechanical information to the different vendors and different subsystems. So it's extremely complicated. One of the things that I really enjoy about the project that I've been involved from the beginning and is still evolving as we go through the project here in construction is some of the handling and integration and maintenance access while we're on the telescope. If you look at the images on the left-hand side, you can see the integration of the M1, M3 mirror into the telescope. If you look just below that, you can see the integration of the M2 system into the telescope using the dome crane. And then on the right, you can see the integration of the camera assembly into the top end of the telescope. One of the challenges was getting access to the camera while it was in the telescope, in basically the center of the telescope. So we came up with some unique ideas for some extending platforms that go out and actually get you right up next to the camera. One of the real things that I enjoy about my work is going from basically concepts to working hardware. And you can see some images of that hardware here. Early on the right, the upper right-hand side, you can see those towers there. That was a microthermal array that we used to do some site testing and determine the final height of the telescope. Below that, you can see some sky brightness monitors that were used on site to determine how close we could actually observe to the moon. In the center, you'll see some images of the M1, M3 container, and we had to move that from the Mirror Lab here in Tucson to a hangar located at the airport. There were a lot of challenges with this. One of them was basically, how do you move a very large piece of equipment down through the streets of Tucson and then through a gate that wasn't actually big enough to fit the mirror container through? And then also, how do you offload that mirror container into the hangar without using a crane? So there were a lot of challenges there. And then all the way on the left-hand side, I was responsible for disassembling and removing the Calypso telescope from Kitt Peak and relocating it to Tucson for refurbishment. There was some challenges with this because the documentation for the telescope was not very clear as to how it was to be disassembled or how to handle the optics. So I had to do a lot of reverse engineering to make that happen. So, thank you.
Hola, hola, hola. So my name is Constanza Araujo. This is my Confluence picture. But most of the people know me as Connie. And also I discovered once on my door, Doña Constanza, so it's my kind of nicknames. My official job title is a Telescope and Site Lead Optics Engineer. I'm also the M1, M3 cam. I have worked as optics engineer at ISO, the MPE, the Max Planck for Extraterrestrial Physics in Germany, and the University of Cologne. And before joining LSST, I was working in the Gemini Observatory in La Serena. I have a dual citizenship, so I'm Chilean and German. This is kind of okay most of the time, but this year we have the Confederations Cup. I know here there are many soccer fans, so we have two games, Chile against Germany. Well, I will not comment further on this. Some of the fun facts, I was born in a very small city, and with the years it's getting smaller and smaller. In the south of Chile, it's called Trayen. So if you have problems pronouncing my family name, Araujo, Araujo, when you get like birthplace, Trayen, so I'm always in trouble. So I'm a bit my story with LSST. So while I was waiting for my working visa in La Serena to move to Tucson, I had the opportunity to attend the first stone ceremony. And this was actually the last time I was in the summit. So I'm looking forward to see the building with my eyes in the coming future. After moving to Tucson, I also was part, as John mentioned, of the transport of the M1, M3 mirror container from the U of A to the Millionaire facility. So you can see also part of the crew. This was like at 3 in the morning, waiting for this big transport. I'm also, one of my responsibilities is to babysitter this container, so every 2 to 3 months I go to Millionaire and inspect there is no graffitis. I have a count of the population of spiders on the container, so everything's fine. So as telescope and site team member, I also participate in several reviews and inspections, so there is some pictures with some review with part of the team and Mountain View for the exapotan rotator. Some inspections in the very early stages of the mirror cell at Kate Industries, and a recent picture of the coating plant FDR in Germany. So no doubt I'm having a great time these 2 years I've been in the project. But not everything is fun, so sometimes, at least every 2 years, we need to write a technical paper and attend conference and give technical talks. Here, this was a small astroengineering workshop in Chile, so where I was asked as a Chilean optical engineer working in one of the new telescopes that are going to be built in Chile. I mean, we have GMT and also EAGLE-T in the north of Chile. And the idea was also to inspire the younger generations, so I get together with a group of like high school students, and I hope I motivate to pursue a career in engineering. Also, I'm a proud member of the Society of Women Engineers, and I have represented with some colleagues here the Aura and LSST in this last year conference. You can see in the lower part of the picture, this is a group of women engineers and representatives of the different observatories. So there was GMT, TMT, ISO, Space Telescope, Gemini, and LSST. And also, I'm also a very proud member of the organizing committee of the Chilean National Day celebration in Tucson. So I hope you have in your calendars the 15th of September, we're having this year celebration. But my prime focus, like in optical terminology, M1, M3. I'm the M1, M3 cam, and I'm also keeping the countdown. In 41 days, this was yesterday, today is 40 days, we are preparing for M1, M3 cell integration. So my work is not only to coordinate the hardware delivery of my main vendor, this is Kate, so on one side you see the surrogate and the cell, these are my main hardware, but also the internal work of the team. So everything goes inside the cell, we are building this in-house. So here are some pictures of our team. I need that team picture also, part of the conference, and also some of the meetings. So thank you very much. This story is to be continued.
Hello. It's okay. Good morning, everybody. I'm Freddy Muñoz Arancibia, the Summit Integration Engineer. It's nice to be here, speaking on behalf of all the Summit crew. I'm a mechanical guy, mechanical person, and I have been working almost a decade around the Andes Mountains in astronomy projects deployment. One of those mountains being the highest one in the world outside the Himalayas Ridge, flowing from, for example, site testing to indeed equipment installation and then physical instrument commissioning. My last job there was next door in the CDIO Blanco telescope for the dark energy camera instrument that you saw in that picture. In the fun fact, is somebody in this room Irish? Oh, for all of you know, I born in St. Patrick's Day, March 17. So next March, you send me a postcard, please. I will really appreciate it. So what we do up there, basically, all of you in your project areas, you have your own subsystems, and they require your own integration. But we need to integrate all of you in the summit, which is a very not that large space. So if I walk 2 steps in the wrong direction, I fall down the hill. So we need to coordinate a lot of very, very large pieces. So it's basically put things together, but as to play a large-scale chess game with 10 tons weight pieces. This requires a lot of coordination between different vendors, including domes, the elevator, this room size coding facility, a lot of trenches, digging, cranes, all that kind of stuff. And the base of that, it's detailed planning to control the interface, a lot of rigging and lifting, which I do the most. And all of this in a very rush environment. I mean, the change daily, there is constant constraints, and a lot of people moving around. For example, we will see this scenario now. This is a common picture of a cutting-edge shipping and logistics system, because every large project in these mountains requires a very, very suitable donkey's army. There's a very reliable machine. So basically, as the construction grows up, then we move to large-scale equipment transit, assembly of different things, control, monitoring, and for example, that picture is for the large dome azimuth track. And to achieve what? Because our final goal there in the summit is to replicate what you do in your own laboratories or factory test. So by the end of the day, we have something like this installed on the mountain. And I want to use this time just to show the current status of the picture with very bad weather. And I use this time to thank everybody there because, as mentioned, all of this is possible due to a large amount of workers all around the summit working hard and very, very dedicated on this with high precision. That creates what we have in front of our eyes now, which is the site moving from this condition to this condition and as it is now, and growing up to the sky. Thank you so much.
Hi, everyone. Okay. I'm J. Matt Peterson. I'm more than just the mononym, which you'll always hear, which is just J. Matt. So I'm a generalist software engineer, and I have a background doing all sorts of different things, and including let's see, what do we have? DMV software, reliability engineering prediction software, chip scale packaging and manufacturing, cloud and scientific pipelines and bioinformatics. And that was with Cyverse here at U of A. I'm previously with DM Square, where I did Get LFS and the Conda builds, or the recent Conda builds, and an ELK system, which stands for Elasticsearch Logstash and Kibana. And then right at the end, RabbitMQ. Since then, I've moved to EPO, and I'm the first technical person, minus Ben, who's the project manager and has a technical background. So I create technologies and amplify discoveries and catalyze interest in LSST. This is my one sentence that's supposed to describe what I do. And since I'm pretty much the only person on EPO and the only person that's making, like actually building these things out right now, this tends to be true. Looks like this year our goal is to expand and hire about 5 people, which is great. I thought this quote was appropriate. I'm not going to try to say this French name, but it's the guy that wrote The Little Prince. And you can read it here. It's totally accurate. This is like super important to us. Okay, I'll read it. If you want to build a ship, don't herd people together to collect wood. Don't assign them tasks and work, but rather teach them to long for the endless immensity of the sea. Right? That's the point of EPO, in my opinion. So I wanted to just give like a couple, treat this more like a proper lightning talk and actually pitch something. So first, I'm pitching EPO, and second, I'm pitching like using engineering to actually amplify and be part of a catalyst for EPO. So there's 2 parts. I've just started, like in June, so there's 2 parts so far. One part of what I've been working on is the science notebooks, and these just extend DM's system directly. So we get a lot of, there's a lot of bonuses that you get, like everything is shared. And we can push things like user experience and user interface improvements back to DM. And then we also can pull in all the good real science bits that are super important to meeting EPO's needs. And second, there's the Sky Viewer, which is far more accessible for the general public since it's relatively simple. Right now we're using Aladdin Light in Aladdin to create it, which is uses hips and heel picks, which integrates really well with the science notebook. So already there's an iPi widget that integrates directly with the science notebook. And finally, I would just like to say that I am open to hearing everyone's ideas. We have a lot of experts that go really deep in all sorts of different areas. And EPO can use your input, like something that might be out of scope for whatever you're doing may very well be in scope for EPO. And finally, exactly how we do movies in time domain, I think it's still an open question, like how to make it really awesome and make the general public excited about that. So if you have an idea about how to do that and how to integrate alert streams or even do it later on, we're open. Come talk to me. I'm jmatt on Slack or Twitter or GitHub or jmatt@jmatt.org or jmatt@lsst.org. So yes, send it to me. I'm interested, and thanks.
I can use a keyboard. Good morning. My name is Bo Shin. I'm an associate scientist on our LSST project. My professional background is in experimental particle physics. For my PhD thesis, I made some precise measurements for testing calculations in the quantum field theory that describes the strong force. So as most of you know, probably, the strong force is what holds quarks and antiquarks together to form protons and neutrons, and also what holds the protons and neutrons together to form the nuclei. But I have a question for the audience here. So how big or how small is a quark? How small? Okay. So the answer is, according to our best theory, quarks are point-like, meaning they are infinitely small. Experiments show that they are no bigger than 10 to minus 18 meter. That is how small they are. So one day I decided that I want to do something big. Everybody here likes to do something big, right? So the universe is big and it's expanding. And the better news is the expansion is accelerating. So here I am in this world of big mirrors, big field of view, big data, and big science. But soon after I made the transition, unsurprisingly, I found out that, at least for my job, no matter it's big or small, it actually requires the same set of skills, meaning analytical skills, modeling, simulations. I deal with statistics and systematics, and of course, I do a lot of programming. So to summarize what I do for LSST, I only have 4 words. That is technical system performance analysis. So most of the time, I work as a member of the project systems engineering team. I want to say that I really enjoy working in this team, in this environment, because I get to interact with all kinds of excellent people from across the project, across the subsystems and the vendors as well. And I also enjoy working on subjects across the disciplines that are important for the performance of LSST. So my day-to-day job has a lot to do with the point spread function. How big they are, how elliptical they are, and how it's affecting the detection limit of LSST together with throughput and other factors. In order to do that job, in the past few years, I've been learning quite a bit about things like optical testing, mirror fabrication, optical defects. I wrote code I wrote the LSST wavefront sensing software code, and I wrote the active optics control code, and I built an integrated model of the LSST observatory. And recently, I started transitioning into the commissioning effort. So at other times, you will find me wearing my scientist hat. So when I'm doing that, most likely I'm still thinking about the point spread function. So here, just to show some example plots. These are from some recent work with Joko and others. Just briefly, on the left-hand side, you have the seeing wavelength dependence power parameter versus the seeing itself using the SDSS strap 82 data and the comparisons with the von Karman atmosphere model with different outer scale. And on the right-hand side, you have the PSF size spatial structure function using the same data and comparison with full sim simulations and CFHT measurements. So that is the sort of thing I do. If you are interested in similar things, please come talk to me. Thank you very much.
Hello? Great. So awesome. That was our first set of talks. And now we're going to take a little break from lightning talks. The first thing that we're going to do is invite Lucienne up. I butchered the update on Unconference and how that's going to work. So she's going to go ahead and fix that. Thank you, Lucienne.
Okay, butchered might be a little strong. Good morning, everybody. Just a little bit of clarity about unconference session suggestions. Just so you know, anything that you want to have a session on, you can have a session on. There is no selection process, anything like that. The 12 noon deadline is just so that we can get an idea of how many people are planning on attending sessions and how many suggestions there are. So that will allow us to do nominal room assignments. When the unconference happens, we're going to congregate out here by the board. There'll be a couple minutes for people to suggest additional sessions and to find rooms for them. Your session can happen in any of the assigned rooms. You could even go to the pool. It's really up to you, but you can talk about whatever you want. So when the unconference starts, we'll gather out here for a couple minutes. We'll talk about some additional possibilities. You can check where your session, if you suggested one, has been assigned, and then we can all go on our merry way. All right.
Okay, great. So we're going to try, there were two things that we had planned to try, and it's been suggested that the first one may not be working right now. And so this was a chance for everyone to contribute. What do you do for LSST? And there was going to be a word cloud popping up real time. But let's go ahead. Oh, look, the movie's in there, Chris. So Chris Montgomery, our training coordinator, had this fun idea to populate a Google map showing where folks are going to be for the eclipse next week. You might be where you live, you might be somewhere else, you might be traveling to see the eclipse. I didn't know there was such a thing as a Google map until yesterday. I know what a map is and what Google is. So he's made this URL shortener here that you can go to and then click on where you're going to be. And the idea is that we'll display the aggregate results, sort of seeing where the broad LSST community is going to be. I think maybe at tomorrow morning's plenary session or some other appropriate time. So you can try to go to this URL now. If you can do it on your phone, or if the network is snappy enough, or you can just write it down, and we'll post it. Let's post it in the Slack channel and other venues that folks are here. Maybe we'll send it out via community and other things. So that's sort of a fun thing. So since there may be a technical limitation to do this, and I still want us to take a few more minutes break before hopping in and seeing where's all my light. I'm like a Luddite here. I think we're out of PowerPoint. Could you just, click on it?
You are.
Now, would you like to use this microphone or this one? Yeah, and so hold it pretty close. There was a little, sometimes people hold it far. And do you like to use the presenter? Or you can also click on the down arrow once we've got PowerPoint rolling again. Okay. And see my computer there? Mm-hmm. I'm going to wake it up, and I'm going to put a 5-minute timer so you can see exactly how much time you've got. Okay, thank you.
Are you going to use the clicker?
So
this one is for advancing.
Okay, thank you.
And then screen share.
Okay, welcome back. That was fun, and I wonder what's happening on Netflix and in the bar. So my name is Xinfang Qiang. I'm a research scientist at NCSA, University of Illinois. I was born in Taiwan. I came to the States more than a decade ago and went through school, and I joined the data management subsystem around 2 years ago. I work in the data facility at NCSA. In particular, I work in data processing. So over the last 2 years, I worked with LSST. I worked on multiple different projects, and some were quite different from some others. But recently, I've been mostly trying to provide offline batch processing service facade to my DM colleagues. Particularly, that means I execute processing campaign and make sure the data products are generated the way they are intended to be generated. So to give you an example of what that means, back in May, just a few months ago, we carried on a large reprocessing campaign using HSC data. So HSC Hypersampling Camp had their first data release earlier this year. So we took all of those data, around 6,000 visits of the raw input for this exercise of reprocessing. So if we compare those numbers to LSST number, in terms of the number of visits, that's not even a week of LSST data. And if we compare that number in terms of the data size, that's not even a night of LSST data. But before LSST happened up and running, giving us the data, let's just pretend this is big data and we could do some exercise with this. So we carry out the large processing campaign, and we use our own DM software stack and run all of these on our own verification cluster that's physically located in NCSA. So on the right-hand side, you see all these pictures. They are our LSST data management machines at NCSA. In the right circle, it shows where the verification cluster is. So over the course of around a month, I submitted more than 10,000 jobs to this machine. And that means I took more than 500 code weeks of the computing time from the verification cluster. To give you some ideas what that means, it's that if we were to run this on one CPU machine, it would take more than 9 years to finish. So I don't recommend you running that on your laptop. So I was responsible for resolving any issues that came up during this reprocessing campaign, and working with my colleagues at NCSA and Princeton to resolve all the issues. After around a month, we ended up with more than 11 million of files, which is more than 160 terabytes of files on the disk that my DM colleagues have been using for more exercise. So on the left, you see this curve. That's how this data accumulated over the reprocessing campaign. And so just every day, I put more and more data on the disk. And I know I'm not the favorite of our storage engineer. So on the right, you see some example pictures, some beautiful pictures that our software stack generated. And on the lower right is how different science pipelines take CPU time during this campaign. So with that, we instantiated the initial batch processing service facade, and we are still working to transition into the next phase of the service, trying to improve the production system. And we plan to run our next reprocessing campaign later this year, hopefully with an improved system and progressing to the operation. Meanwhile, I also process a small set of HSC data every other week, so my DM colleagues could use these for integration tasks, for QA, for verification, validation, and so on. So that's the focus of what I do recently. I also work on any other things that to gain operation experience and to make the operation and production happen. Thank you.
Hello, I am John Perico. I'm a research scientist at the University of Washington in the data management team. As you can see in the photos, I'm a climber, a biker, and a fiddler. My claim to fame on that last one is that my band, shown in the picture, has played music at IKEA multiple times, and we've been paid for it. Before coming to LSST, I worked with SDSS data, galaxy spectroscopy and galaxy clustering, and most recently I worked on the SDSS operations software to make sure that the telescope could work and take data every night. Shown there is a picture I took of the SDSS telescope taking a calibration exposure. Some of you here right now are probably looking forward to commissioning when LSST starts to actually operate, and you too will be able to receive phone calls at any hour of the night. And to each of you, I say that I am both sympathetic and a little bit envious. But what am I doing for LSST? I am responsible for JointCal, which is a piece of software originally written by Pierre Astier of IN2P3, which will fit the astrometry and photometry across all CCDs on the entire focal plane using all available exposures plus a reference catalog simultaneously. And we need this in order to meet our science goals. And the way this works is we build up a model of the contributions to the distortions and the absorption of photons as they come down through the sky and go through the atmosphere, the telescope optics, the camera optics, the inexact positioning of the CCDs in the grid and the imperfections in the actual alignment of the pixels in each individual CCD. And this model potentially contains thousands of components, so we're going to need a lot of data to actually reliably constrain the model. But fortunately, not enough data is not a problem LSST is going to have. But more than just a lot of data, we need good software in order to actually perform this fit to thousands of exposures in a reasonable amount of time. And that's what I'm building. So you've seen some pictures of the hardware components that people are building. This is a little snippet of the most recent component of the photometric model that I'm adding. JointCal is mostly written in C++, which is a bit of a challenge for me because before coming to LSST, I did most of my work in Python. And we need to write this piece in C++ for performance reasons. But while I'm currently extending the model, we can actually run JointCal on currently available data to test it out. And as an example, Dominique Boutinier has been reprocessing CFHT and HSC data using JointCal, and you can see the example here comparing processing of single frames with JointCal's processing of a number of HSC full focal planes, where the relative astrometric repeatability improves from 40 milliarcseconds to 7 milliarcseconds. So that's already, with the current simple model that's in JointCal, approaching very close to the science goals using HSC data. And this is just with a simple model. As I improve the model, as we build the model up, this can only get better. But more than just meeting our astrometric and photometric science goals, you can learn some interesting things when you have a robust model like this of the whole system. Gary Bernstein has been doing some really excellent work for DECAM. There's a link to their paper there describing their astrometric model for DECAM using a very similar style of model to what we're building in JointCal. The plot here is from the paper, and it's of the stacked residuals of 850 exposures for one CCD after you've taken out all of the things that you know about the atmosphere, the optics, the positions of the CCDs, and the imperfections in the pixel grid. That radial feature you see there is actually from the edge of an electrical connector on the back of the CCD, distorting the pixel grid. So we hope that as we build up a really good model of our telescope, we can find some of these interesting features in the data and end up producing the most accurate photometric and astrometric catalog of any ground-based survey ever. And of course, this is going to be an ongoing project through commissioning and observation because we don't know what we don't know about the system until we actually start taking data. But I look forward to helping us find out. Thank you.
There's a clicker if you want, and I'm going to put 5 minutes on my computer for you to see.
Okay, hello. So my name is Sven Hermann.
Close to the mic. Yeah, close to the mic.
My name is Sven Hermann, and my job is systems electronics engineer at SLAC. So by now I have more than 15 years of experience in the design of readout electronics for detectors. First, I worked at the Max Planck Institute for Extraterrestrial Physics in Germany, because I'm born in German. There I was working on the focal plane instrumentation of a number of X-ray satellites missions, most of them not launching. So there was particularly the PN CCD readout of eROSITA that is hopefully still going to launch, and the depth-fed readout of XUS and IXO, which is basically canceled, but now it's revamping as Athena. Then from there I moved to SLAC because SLAC has LCLS, which is a free electron laser, and that's basically an X-ray laser. And so you need X-ray detectors for an X-ray laser to make pictures, and so I worked on there on X-ray detectors. Now, there is an astonishing similarity between the fully depleted X-ray detectors, which we use to detect X-rays, and the deep depletion, fully depleted backside illuminated CCDs, which LSST is using. And so then in 2014, I jumped on the LSST project working on this, basically the same topic, just at different wavelengths. Okay. So in one sentence, I work on CCD readout electronic boards for LSST. They are also called REBs. Their design, test, characterization, and the full-scale production. Okay. So how does that basically look like? Well, the design is we obviously have requirements and specifications, and we have the schematic design and the simulations, and then we have a large amount of testing of prototypes. I'm a big fan of prototype test-driven development, especially in our field of science that has proven to be working. A single channel of LSST readout electronics is actually quite conservative. But the pure scale of the project, having more than 3,000 channels crammed into the cryostat just under the CCDs, that makes it a challenge and makes it, frankly, quite awesome. So by now, we obviously have finished all our design work. We have settled on a final design. And this is the REB5. And so now it's gonna basically doing the production. And it's one thing if you can make a prototype of one board and show, hey, that works, that's great. It's a completely different thing making 100 of them, which all work in the exact same way, in schedule, in budget. And so we set up this production thing where we also have not only to manufacture and assemble those boards, but also to test them. Every single board has to be screened for its performance, has to go through a number of environmental tests. So here you see boards which are located in the oven, where they go through thermocycling and a burn-in test, everything aboard. And also the boards in the vacuum chamber down there, that's the residual gas analysis, because every single board is screened for its outgassing performance, because only boards which do basically not outgas below what we have specified will go into the camera. And then finally, a package of boards is going to be packed in these nice carry cases and is sent to Brookhaven, where Brookhaven takes the boards and then assembles ScienceRaft RTMs. I'm also doing the job, so you've seen boards, these are ScienceRaft boards. The boards on the previous slides were CornerRaft boards, so I'm doing this both for the subsystem of the 4 little CornerRafts, but also the 23 much bigger ScienceRaft packages. Okay, that's basically what I wanted to say. So it seems I have 20% schedule left, which I can give back to the management.
Do you want this mic or that? Okay, great. Great. And I'll put the 5-minute timer right on that computer, and then you can see it. Great.
Hello, can you hear me?
Yeah, good, that's good.
Okay, I'm Justine Haupt. I work at Brookhaven Lab in New York. I've been on the project since 2009. Let's see, Brookhaven Lab, New York, 2009. I'm an engineer. Before 2009, so pre-LSST, I was teaching violin and piano in people's homes. And I was working at that public observatory you see on the bottom right there. And that's where I met my husband. This is kind of just a collage of interests, because, you know, because it is. My husband's in the back of the room. He's David. There he is, in the middle, yeah. And we do a lot of things together. We play traditional music. I'm also a fiddler. You see us there in North Carolina. We love cats. There's a big 3D printer working on in the basement. It's bigger than a refrigerator in the middle. We're consummate nerds. There's a picture there of us in front of the mothership from Close Encounters of the Third Kind. That's on display at the Udvar Hazy Center near Washington, D.C. I'm a pilot. I had an old plane. I sold it. Let's see. That's a corrected Gregorian telescope I've been working on just for fun. It's not done yet. There's a few projects I haven't finished. The thing on the bottom left is a 35 millimeter movie projector that I was trying to save from oblivion, but that fell through because I don't text. But those are cool. So anyway, I'm going to show you some, oh, what do I do? Okay. Mechanical and optical design for the sensors. We're developing the sensors at Brookhaven, producing them, and more recently I'm working on the commissioning camera. So I'm just going to show you a bunch of pictures of all the cool things I've been able to make. I think they're cool. The one on the top left is one copy of many of the full RTM, the 9CCD module testing cryostats. It's kind of a small version of the camera. There's made an in-vacuum iron 55 X-ray exposure device, which uses a PCB as the stator for the actuator. So that's kind of neat. There's a pinhole image of me from one of the early engineering grade ETV sensors. Let's see. We did some telescope testing. That cryostat on the left, there's an early version on the bottom left. That's going to become, a version of that will become the commissioning camera cryostat. You can see on the top left, it's named Curzon. The other cryostats of that kind at Brookhaven are named Esri, Jadzia, and Tarias. Does anybody know? These are the DAC symbionts from Star Trek Deep Space Nine in reverse chronological order. The other single sensor cryostats are named after some of the other captains too. Here's some of the more optical things I've worked on. On the top left, it's an f1.2 point projector based on a Schwarzschild objective. There's kind of a refractive element in there, some other changes. That photo in the middle bottom is, it looks like a product photo, but that's entirely built in-house, what it wound up looking at and you can see also on the top left what the re-imaged point looks like with the diffraction from the central obscuration, LSST-like central obscuration, atmospheric turbulence simulator on the bottom left, the single sensor test stand at Brookhaven, optical tunnel, another optical tunnel for the 9CCD tests on the bottom right. You can see how dark it is. It's good, right? There's a light shining in there and it's still dark. But there might be some arguments about how dark it is. So anyway, now I'm mostly working on the commissioning camera cryostat. This is what it's basically going to look like. It should really look like that. That's the rendering from just last week. 37 seconds. The one on the right is another copy of that camera test chamber at SLAC, and that's not ComCam, but it'll look similar. And that's it. Okay.
Do you want this or that? Just stand close enough to it. Justine did great. Great. And Travis, I'll have my 5-minute timer here.
Yep. All right, so like the problem kid in class, I guess at the back of the room, I get to pull up the last of these talks. I am Travis Lang. I'm a mechanical engineer at SLAC. I work on the camera integration and test. I have been doing that job for 3 years. I was actually brought to SLAC just for that position. Before that, though, I worked at Lawrence Livermore National Lab on the National Ignition Facility. I was responsible for doing many optical mechanical projects, but my main focus there was adding a short pulse high energy laser system to the NIF, the National Ignition Facility. So in the upper right corner picture, that is the final focusing and turning mirror for that system. You can see the reflective glass as well as all the black glass there is basically stuff to to absorb backscattered laser light. And the lower right image is inside of the compressor vessel, which actually took the laser pulses and shortened them from nanosecond durations to picosecond durations using a series of diffraction gratings. And both of these are in extremely large vacuum chambers that were held at about 10 to the minus 5, or nearly 10 to the minus 6 torr. So I'm going to take a short little tangent now and tell you a little story about me. When I was 2 years old, I had a big wheel. Does anybody remember what a big wheel is? Yeah, all right, good. All right. So I used to ride that thing all over the neighborhood and even beyond the neighborhood, you know, across town, on the country roads to the next town. And so my parents would enlist the helps of friends and neighbors, the family dog, and even the local boys in blue to help find me. So I got the nickname of Traveling Travis. And so that has kind of stuck with me. And so, you know, a little over 10 years ago, I decided to take a little break from engineering. I became an adventure guide, so I took people on week-long trips through a lot of different places. So I spent 4 years up in Alaska. I spent a lot of summers in southern Utah or Vermont or Eastern Europe, and then some winters in some tropical locations. So I was a bit of a sun chaser, basically, following the weather to nice, warm, sunny places. Except for Alaska. It's never sunny and nice in Alaska. So on the, sorry, in the upper left, that's me as a mahout, or elephant driver, in Thailand, and on the bottom picture there is in front of the Harding ice field in Alaska. So what is it that I do for LSST? Well, I'm currently trying to, we're planning for how we assemble and test the camera. So this graphic has been shown at many different reviews and by many different people. I'm going to go through it really quickly just because I'm going to talk about a couple components of this in the next slide. So we have the 4K by 4K CCDs that Brookhaven is integrating into the Science Raft Tower module, or the RTM. And those, along with the corner raft version, which has the wavefront sensor and guiders, are installed into the cryostat. And we also have the L3 lens assembly, which is both the final corrector and the vacuum barrier for the cryostat. We have 5 filters in a carousel. We have the exchange system, which does the handoff of switching those filters. The camera body, the L1, L2, the first 2 corrector optics, the shutter, the utility trunk, and the auxiliary electronics, which are all the electronics which are required for reading out the images. So what is it that I fear the most on LSST? Well, frankly, it's putting these Science Raft Tower modules into the cryostat. We have roughly 500 microns of clearance around the CCDs of adjacent RTMs, and those raft towers are roughly a half meter tall. So we have a 500 micron clearance at the CCDs, and we have about a millimeter of clearance during installation at the other end of that RTM. So it's a very restricted system. And without any sarcasm at all, I would just love to thank the folks who decided that having such a small gap was a wise idea. So how are we solving that? So we've decided that we're going to have a system of high accuracy stages, which will do the positioning and then the draw of the RTM into the cryostat. We have 2 of the degrees of freedom of that system are going to be a set it and forget it based on metrology, and I'm done one second, and 4 actively controlled axes. So it's a real challenge. I could bore you to sleep with this system, but hopefully next year I can show you some images of a whole bunch of raft towers installed into the cryostat. That's it.
Okay, great. So I would like to thank 12 speakers who all gave impeccably delivered and timed talks, and I would like to thank everyone in this room for what you're doing for LSST. So my only announcement is that Chris Montgomery confirmed that trivia will begin at 7:30, and if folks want to congregate around 7, there'll be a cash bar, a chance to make your trivia teams and start interacting before the games begin. And I think that we're good on announcements. Nothing else before the break? Great. So thank you all very much.